In this case, the length of the crank arm is less than the radius of the wheel. If you pull forward, the wheel rolls forward. In case 2, the length of the crank arm is longer than the radius. In this case, if I pull on the string to the right, look what happens. The wheel moves to the left. In our final case, the length of the crank arm is approximately equal to the radius of the wheel. Here again, I apply force to the right and watch what happens. I have to pull pretty hard. And eventually look what happens. The whole system rotates about the z-axis. This is because I added rubber.
It's quite simple, it's not any paradox. So before giving the reason, I would like to give some idea about the concepts that are involved here. That is moment of force or torque and the concept of point of application of force. Now first of all, what is moment of force or torque? See, suppose here is a body, right? Is an object, and I give a force on it like this. This is F. Now of course the body will execute a translational motion, or in simple words, the body will move forward. But now, if the body is pivoted, pivoted means it is hinged to a point. For example, this door is pivoted at this point, it is hinged at this point. If I apply a force on this door, it is hinged to this point, it is not free to move. So if I apply a force on this door, then it will execute a rotational motion. Similar happens for this body also, that if I apply a force on this body like this, the body will rotate. The body can also rotate by another way, that is, if I apply two forces on this body, these two forces are parallel, equal, but not along the same line, means they are parallel, they are equal and opposite in direction of course, but not along the same line, means I can't apply any force like this, then also the body will rotate about this point. And this rotational effect of force is called torque, and the quantity that is used to measure this rotational effect is called moment of force. And the way we measure this torque or rotational effect is called moment of force. We denote moment of force as tau, which is equal to R cross F. R cross product with F. Now this is R is vector also and F is vector. Now this is a quite mathematical integration, so let me explain it theoretically. It is a product of the force and the perpendicular distance from the line of force and the pivoted point, or the point about which it will rotate. Let me repeat my words. I told it is a product of the force and perpendicular distance. It is not cross product, it is just multiplication. And the R is a perpendicular distance. Suppose I am applying a force like this, the body is hinged about this point. Then the perpendicular distance from the line of force, this is the line of force, the perpendicular distance is this. The product of the force and the perpendicular distance from the line of force and the pivoted point is called the moment of force. It is a quantity by which we can measure the rotational effect or torque. Now this was the concept of moment of force. Now comes the concept of point of application of force. That means, suppose there is a body like this. Now, in which direction it will rotate? It is suppose pivoted at this point. Now, in which direction it will rotate? What I told? In which direction it will rotate depends upon two factors. That is, direction of application of force and point of application of force. First one is direction of application of force, and number two, that is second point, is point of application of force. Now direction of application of force. Suppose you are applying a force in this direction, then of course the body will rotate in clockwise direction, right? Now if you are applying force along this direction, then the body will rotate anti-clockwise. So the direction of rotation, whether clockwise or anti-clockwise, depends upon direction of application of force. Now about point of application of force. Now leave this. Suppose you are applying force in this direction, the body will execute rotational motion in clockwise direction. Now what I do, that instead of changing the direction of application of force, I change the point of application of force, like this. I apply a force at this point now. Now will the body rotate in clockwise direction? Of course, it's common sense the body will rotate in anti-clockwise direction. And this is the greatest concept or the main point required to understand that paradox. It is not paradox, it's a quite simple, there's a quite simple reason behind that. Now in the video, the body is executing both translational and rotational motion. Now it is executing both translational and rotational motion because the body is free to move. So here we are not concerned about the translational motion, we are just concerned about the direction of rotation or the rotational motion, because that will only tell in which direction it will move. Now as per the video, this was the case 1, where the this rod or anything what it can pipe was shorter than the radius of the wheel, and I was applying force, or the man was pulling the rope like this. Now if he is pulling the rope in this direction, it is of course applying a force in this direction. Now think here, which is the pivoted point? Of course, only in case of rotation, this is the pivoted point. This is the pivoted point, or this is the point about which the wheel is rotating, right? Now this is my line of force, and this is my perpendicular distance from the line of force. So in which direction do you think it will rotate? Of course, in clockwise direction, right? Now if this rotates in clockwise direction, the wheel also have to rotate in clockwise direction, so it was moving in this direction. Now in the second case, when the length of this rod was greater than the radius of this wheel, then the wheel was rotating in this direction. This is quite simple. Let's see. This is the line of application of force. This is the perpendicular distance from the axis, right? From the point where, from the pivoted point or the axis. Pivoted point means if the body is rotating about the pivoted point, then this is the axis passing. Then the axis is passing through the pivoted point. So here it is the axis. So from this pivoted point, from the axis, the distance was this. Now tell in which direction this will rotate. Of course, it will not rotate in this direction, rather it will rotate in the, according to this axis, it will rotate in this direction. So if it has rotated in this direction, then the wheel has rotated in anti-clockwise direction. And so it was moving, the wheel was moving in this direction. Now in the third case, when the length of the rod was equal to the radius of the wheel, and when the force was applied in this direction, the wheel was not rotating. And the reason is quite simple, that we know that the moment of force tau equals to R cross F, which is equal to RF sin theta. Here R sin theta is the perpendicular distance from the line of application of force and the pivoted point, right? Now this is the pivoted point and this is the line of application of force. So what's the perpendicular distance? Of course it is 0. So moment of force is also 0. So it was not rotating. That's simple as that.